The next video I'm making just for fun, I guess. There's this video actually will not be part of any video series. I just thought it would be a interesting thing to look at after viewing continuing hypothesis is true relativity and cosmology. I figured why not do a video like this, and so I also decided to ponder continuing hypothesis and how it can be applied to cosmology and the like. And so here my not so well drawn diagrams, because again it's chalk. What can you do with chalk in our artistic sense? Anyway, so basically, if you guys studied quantum physics before, there's very important units of measurement, Planck scale measurement. It's used extensively in quantum mechanics, and there's also a Planck's constant reduced, which is basically Planck's constant divided by 2 pi. You can look this all up. I mean, it's all just on the internet, but essentially, I just thought it would be interesting to take a look at, how can this be applied to astrophysics. Astrophysics is pretty interesting to look at from, theoretical standpoints, because a lot of overlapping areas of physics play into it, such as string theory, quantum field theory, nuclear astrophysics, like beta neutrinos and antineutrinos and things like that, all are part of it. And then there's of course, string theory, quantum field theory, and a bunch of other stuff that kind of ties into, of course, general relativity, Einstein's work, and that sort of area. Anyway, so without further ado, I figured let's talk about a little bit about black body radiation. Well, that's all about. Basically, black body radiation is it's like an idealized form of how a stellar object in space will emit light depending on how hot it is, and basically that's governed by a function, of temperature and velocity of the light, I believe. And so here we have 2 times Planck's constant, v cubed over speed of light squared, and then it's 1 over e to the Planck's constant times v over the Boltzmann constant times t minus. Basically, Planck's law will be, I'll do a separate video series on all that. But anyways, the point I'm trying to make here is actually okay. So how can we tie continuum hypothesis into all of that? Well, let's examine some parallels between Einstein's theory of relativity and Geiger-Cantor's work. Well, reaching the speed of light is not possible, actually. Well, not from an observer's perspective, and for our technological methods of today, at least, there's no way we can achieve the speed of light ourselves. However, we can get speeds that are pretty close to it. Pretty close to it. And in a way, this can be viewed as an analogy between the set of natural numbers and the set of real numbers. Like the next step of next step of I guess velocity in the physical sense. Now, how exactly do we tie this all together? What exactly does this all mean from a non-philosophical standpoint? Well, that brings us to my next topic, which is string theory. Now, string theory in of itself is not really a proven theory. Essentially, it's a bunch of physicists, not really even a bunch, it's a group, who will believe that quantum mechanics and general relativity, they should mesh together into one, because people, especially scientists, like to find patterns in things. So string theory attempts to find patterns between quantum mechanics and general relativity. And there are physicists such as Ed Witten, who argue that basically string theory, some aspects of string theory are good for describing certain phenomenon, and some are better for others, and maybe it's just all part of a piece of a bigger pie, and things like that. Anyways, that's all theory. Anyway, so how exactly does this work? How does this work out? Well, mathematically, general the light is a matter of reference. It's all relative. Time is relative, because if you bend light, you bend the space time, or you bend the space time around, and by bending the space time around, you can actually alter the course of time. Let me rephrase it. Not alter the course of time, but you can change the speed at which time is perceived. That's why there are things such as time dilation, where you go out of the Earth. You've only been outside for 6 years, but it's 12 years that have passed on Earth. Things like that. It's all depend on how fast light reaches. And it's all relative, essentially. This is Einstein said, it's all relative. All that astrophysics stuff. Some people find hard to wrap their heads around. It's all basically saying time is relative, depending on where you are in the universe, how fast you're traveling, what the I guess the geometric configuration of the space you're in. That depends. That all plays into how time is perceived. So what does that get to mean for continuing hypothesis? Is it possible to combine continuing hypothesis into all this? Because actually, string theory borrowed from one of Euler's set of equations, and actually for the longest time, those set of equations were believed to be purely mathematical, just a mathematical, fun, little trick that mathematicians came up with. But it actually found use. There are actual physical patterns that can be described using Euler's formulas. Now, what about what? I think it's hypothesis could possibly follow this whole thing, because why not exactly? Why not use all the math use all the math we can possibly find, because physics is far. Well, let me rephrase it. It's not really far from solved, but there's still a good chunk of research left to do. I mean, there's the fluid mechanics is not even solved. If like a long time, like centuries studying how water moves and fluid moves. But we've come a long way. I mean, we look at planes. That's all based on research in fluid mechanics and engineering and things of that nature. And so yeah, continuing hypothesis and how it can help astrophysics. This will be something to ponder more in depth. I think I will post some videos more discussing this. But I figured I haven't made a video in a while, so why not just talk about astrophysics? And it was kind of on my mind, and I viewed the video on the on CH is True video series. I figured, and why not talk about some of this stuff? Why not? My next video series, I'm thinking of doing fluid mechanics. Yeah, again, bring that up. Maybe organic chemistry. I'm not sure which one I want to do yet first. And I also need to get a better camera to make those Tekken 6 videos. Anyways, I guess that's all for this video. See you guys in the next one. Hope you guys enjoyed. Just remember to subscribe. Stay tuned to this channel. There's gonna be a lot of cool stuff happening. There'll be a very cool science experiment done at the end of the fluid mechanics video series. It's gonna be interesting. All right, well that's all for now. I hope you guys enjoyed. See you guys later.